Alright, this video then, simplifying fractions and solving for x. So one step further than the previous one. Remember what we said about things being comparable, so denominators need to be the same. So at the moment you have 2 over 1, because remember any number by itself is the same as that number over 1. X minus 1 over 3 is 4x. So at the moment, if I want to make these a single fraction and then solve, I need the denominators to be the same. This has a 1 and this has a 3. So if I want this to have a 3 as well, times by 3 on the top and times by 3 on the bottom. And if I want this to have a 1 as well, well, notice it already has. 3 is the same as 3 times 1, so I don't need to do anything to that. But you could look at it as 1 over 1 if you want to, by making the denominators the same, and then you have a consistent approach, okay? So at the moment I can put these two things together because the denominators are the same. So this is 6, and then you've got x minus 1 in brackets, so be very careful with that, okay? So write the brackets as they are, and then you can have a little think about it, because at the moment you are going to have a minus and a minus involved. So 6 minus x, and then minus times minus 1 is plus 1 over 3 is 4x. So now you have 7 minus x over 3 equals 4x. So if we want to solve for x, I want x equals, yeah? But this denominator is different from this denominator, so likewise we need to make them the same. At the moment this is the same as 3 times 1, so we do actually have the 1 here. But we need this to have a 3 on the bottom, and therefore if we do it to the bottom we have to do it to the top 2. So I'll keep this going over here. So I've got 7 minus x over 3 equals 12x over 3. Okay? So can you see that the denominators are the same? So if you have two fractions where the denominators are the same, that means the numerators must be the same. So can you see that this is 7 minus x equals 12x? So what I could have done in this step here, so I'm just showing you the link with fractions. So at the moment you had this. If we want to get rid of this 3 on the bottom, we could just times up by 3. That's okay as well. So 7 take x equals 4x times 3, so that's 12x. And really what you're doing is you're timesing both sides by 3. So if I times the left by 3, you need to times the right by 3, and those 3's cancel out, okay? So in the end, you end up with 13x equals 7, and therefore x is 7 over 13. Let's try that again. So this time, we've got x minus 1 over 2 plus 2x over 3. So denominators are different, so we'll make them the same. So this one's missing a 3, so I put the 3 on the top and the bottom, and the other one's missing a 2. So we'll put the 2 and 2, and we'll leave that 2 there. So we can multiply this out already, so that's 3x take 3 over 6, brilliant, plus top times top, bottom times bottom, so 4x over 6, perfect. Now we can put this all together, so 3x take 3 plus 4x over 6, because the denominators are the same. So that's 7x take 3 over 6 equals 2. So as we did before, we may as well do the fast method of just timesing both sides by 6, because we don't like denominators in fractions, and we're trying to get x equals by itself. So that 6 and 6 cancel, so we get 7x take 3 equals 12, right? But notice from the previous example that that is exactly the same. 7x take 3 over 6 equals 2 over 1. It's exactly the same as making the denominator the same. So this one has a 1, this one has a 6. So if you put 6 and 6, right, the denominators are the same, and you've got an equals. The denominators are the same either side of the equal sign. So if the denominators are the same, the numerators are the same, and that's important to note. So therefore you get 7x is 15, and therefore x is 15 over 7. Box your final answer. Done. Part C, a little bit trickier then. And we've got lots of indices in here as well. So part C, we have 2x to the minus a half, which we know is the same as 2 over root x. So I did that quite fast. So that minus means 1 over, and then to the half means square root. And then we've got minus 3 root x. So notice here, you've got one term plus another term all over 4x, which is fine because we're trying to make we're trying to put fractions together rather than splitting them apart. So this whole thing can stay as it is, but the problem is we have different denominators here and here. Now it's very tempting to times this by x top and bottom, isn't it? But that's actually the long way. So the key thing to notice here is that you don't need to, I hate this term cross multiply. You're not cross multiplying, you're like seeing what's missing from each fraction to make the denominators the same, okay? So this is clearly missing a 4. So we put the 4 top and bottom, and now that matches. So 4 and 4, that matches. Brilliant. This has an x, and this has a root x. So let's not times it all by x, because that could make things really complicated. Why don't we see x as the same as root x times root x? And therefore you can see that the only thing missing from this was the 4 and a root x, okay? So you're trying to find the simplest factor that they share in common, basically, and then times it by the difference. So 3 root x plus 2 over 4x. Now these have the same denominator, notice. So if we clean this up, this is 8 root x over 4x. Perfect. Minus 3 root x plus 2 over 4x. Brilliant. And now we can put these fractions together. So that's 8 root x minus. Now be very careful. So minus, minus. So minus 3 root x minus 2 all over 4x is 1 over root x. So this gives us 5 root x minus 2 over 4x. Perfect. And now we have the same problem as last time. So we've got things either side of the equals. So the easiest way is to times up by the bottom here and see what happens. So we get 5 root x minus 2 equals, and remember we're not actually timesing up, what we're doing is we're timesing both sides by the denominator. Okay, and that cancels your 4x on the bottom. So that becomes 4 times 1 is 4, and then you've got x over root x. And remember that's the same as x to the 1, take away a half. So that becomes 4 root x. So x over root x is the same as x to the 1 over x to the half, and those powers subtract from each other. So we're going to collect terms because this has a root x and this has a root x as well. So bring all your root x's over. So 5 root x take away 4 root x is just root x. Take 2 is 0. And then bring your numbers over to the other side. Because remember what you're trying to do. You're trying to get x equals by itself. So this becomes root x equals 2, which if x is being square rooted, we need to square both sides to get it by itself. So x equals 4. So a lot more complicated, that one. But hopefully the rules seem to apply as they did before. End of video.